This lecture is all about rocks or minerals and rocks. So we're going to start with minerals for this particular lecture, and then we'll move on to rocks and then soils for this week. So it's a slightly less intense week in terms of content that you have for this particular week. So you'll have um, 5 lectures, a couple labs as well, and then you have your midterm that you'll be doing this week as well. So what I want you to do is already go into Blackboard, go to week 3, go to this week's quiz under assignments and go to the minerals quiz. So you're going to take that simultaneously. I'm going to have you just start with kind of an exploration or a question here. And I want you to think about reasons why rocks and minerals are important and kind of why you should care in the first place. Kind of why would we even talk about this in the first place? So that's kind of your first quiz question. Come back when you're done. In terms of a geologist's perspective on why rocks and minerals are important, basically every kind of geologic process, volcanoes, tectonics, earthquakes, it's related to minerals and rocks somehow, or it involves rocks somehow. So the image on the top left, for example, this is from Grand Tetons National Park, which is formed due to tectonic movements. We have a fault on the bottom left due to tectonic movements. We have things like lava. So lava comes out of volcanoes. Lava is a rock. It has minerals in it. So without understanding rocks and minerals, we wouldn't understand volcanoes. And then the bottom right is coal, a coal mine that I worked on in Southwest Virginia for my PhD. Basically, my job was to try to get trees to grow back up on this loose site, this loose rock. So this is a coal mine, and coal is a fossil fuel that we burn for energy. So rocks and minerals are important in terms of the sense that it helps us from a geologic perspective, but we also use it for all kinds of products as you'll explore in your minerals lab for this week. So just some very simple definitions to start out. Let's define what a rock is. So a rock is basically an aggregate that has a bunch of minerals that are mixed together to create one solid substance or a rock. So for example, this picture here, this is a picture of granite. We'll get to this in the next lecture, but granite is an igneous rock. So it comes out of a volcano. It forms when a volcano magma or lava cools down. And then inside of granite, there's pink minerals. Those are called feldspar. There's some clear kind of grayish minerals. Those are quartz. We have some white in here as well. That's another type of feldspar. We have some black in here, which could be a mineral biotite or amphibole. So the point here is that a rock is a mixture of a bunch of different minerals kind of squished together. So a good analogy for this would be ice cream. So ice cream is one solid material, and then you have different building blocks or different ingredients. Those ingredients are similar to minerals that get built together into one rock. So rocks are made of minerals. What are minerals made of? Minerals are made of elements. So depending on what type of rock or mineral you are looking at, it's going to have different elements from the periodic table in it. What I have done on the periodic table here is I've put a yellow box around the ones that are more common on Earth's surface. So some of the most common minerals on Earth's surface, like quartz, for example, is just silicon and oxygen. So that's these elements here, silicon and oxygen. But there's also a bunch of other minerals that will have aluminum, iron, sodium, magnesium, potassium, and calcium in it as well. All of these other elements that we have on the periodic table, assuming it's not a gas, can also be present in rocks to a certain extent, but these are the more common elements that are found in rocks and minerals. So rocks are made of minerals. Minerals are made of elements. We're going to go down one more scale. So elements are made of atoms, and atoms would be the smallest particle that retains a characteristic of an element. So if you've taken chemistry, you've probably learned atoms have a nucleus, so they have protons and neutrons in the nucleus, and then you have electrons that kind of circle around the outer part of the atom, and atoms are what make up elements. So for example, in our hypothetical diagram here, we have electrons are the gray circles or spheres that we have here, and then we have protons and neutrons are our blue and red colors that are inside of that atom. So rocks are made of minerals, minerals are made of elements, elements are made of atoms. All right, so you got a stop sign here telling you that there's another quiz question that you should be able to complete at this point. Now, if we look at a If you pick up a rock on Earth's surface, or if you pick up a mineral on Earth's surface and you're looking at it, there's a pretty good chance, greater than a 90% chance, that what you have picked up is going to have a mineral in it that we call a silicate. A silicate is a group of minerals that has silicon in it, the element silicon from the periodic table. So silica or silicon is one of the most common elements that we find in rocks and minerals on Earth's surface. And this is kind of the building block for all rocks and minerals that we have, is something called the silica tetrahedron. If I break that word down, silica is a combination of silicon plus oxygen. So we just call it silica. And then tetra means four, and hedron basically means that it has a pyramid shape. So if you were able to take any rock or any mineral on Earth's surface, you stick it under a microscope and you look at it on a very small atomic scale, what you'll see is that it's made of these building blocks that we call silica tetrahedron. So again, tetra, four, basically means that you have one silicon in the center of this kind of pyramid shape, and then you have 1, 2, 3, 4 oxygens. And the way that these chemically bind together, so it probably feels like I'm getting nitty gritty here, the way they chemically bind together, it gives a structure that kind of looks like a pyramid here. So if you take this pyramid, the silica tetrahedron, this pyramid shape, and you link them together, you can form a whole bunch of different minerals that we have on Earth's surface. So if you've ever heard of olivine, it's a green olive-colored mineral that's common in Earth's mantle and on the crust. Olivine is an example of, you just take that silica tetrahedron and have its little pyramids, and if they're kind of isolated and not chemically bound to each other, you can get a mineral called olivine. Let's say that you take those pyramids and you start to link them together with chemical bonds. You can get a chain of pyramids, and that's something we call a pyroxene. If you take one chain and bond it to another chain, you can get something like a double chain silicate, which is what we call amphibole. You can link them all together into what's basically a sheet. If you know what mica is and you've ever seen it, it's like sheets of paper. That is built of these silica tetrahedron pyramid building blocks. Or if you bind all of them together in a very complex structure of all of these pyramids are linked to a whole bunch of other pyramids, you can get something like quartz or feldspar, if you've heard of that before. So what I want to point out is that all of these are things called silicates. That means that they have silicon in their chemical formula. So if you look at their chemical formula, basically you'll see Si in it, or the element silicon. All right, so based on that, what I just verbally said, you have another quiz question here to complete. It's asking you basically what the mineral is. So this blue mineral here is called amazonite, type of feldspar, but it's a silicate mineral. So you got to pick which formula corresponds to a silicate on the quiz. So moving on, we're just briefly going to talk about what a mineral technically is. And then I just want to point out that the bonds, we won't talk about like ionic versus covalent bonds. If you were interested, you could read about it more. There's certain minerals that are held together by ionic bonds. There's some minerals that are held together by covalent bonds. And those bonds, and also van der Waals bonds, if you've ever heard of those bonds basically determine how strong a mineral is. So if you can break it really easily just by bending it, or if you have something like a diamond here that you can't break at all, strongest mineral on Earth. So it's determined by the chemical bonds that hold it together. So if you ask a geologist what a mineral is, a geologist is going to list 5 things that it has to satisfy. If you have a substance and you're trying to determine if it's a mineral or not, 5 criteria that it has to satisfy for us to call it a mineral. So let's go through these 5. First, it has to be natural. So it can't be man-made. An example is like if you have cubic zirconium in jewelry, maybe you have a piece of jewelry that has cubic zirconium in it, that's made in a lab, usually. So if it's made in a lab, it's man-made. It's not technically a mineral by a geologist's definition of a mineral. So that's what I mean by natural. It has to have a natural way of forming. It can't be man-made. It can't be synthesized in a lab. There's also lab-grown diamonds as well. It also has to be solid. There is one caveat to that. So mercury naturally is present as a liquid and can technically be a mineral at some points in time. But let's just say for our class, it has to be solid. So it can't be a gas, can't be a liquid. A mineral also has to have a chemical formula, but everything on Earth has a chemical formula, so that doesn't really help us here. But as an example, it could just be one individual element, like elemental sulfur here, which is a nice yellow colored mineral, or it could be a compound that has different elements. So there's my personal favorite mineral here. It's called labradorite, but it's got calcium, aluminum, silicon, and oxygen in it. So it's a compound, but it still has a chemical formula. So just two more here. In order for something to be a mineral, it has to have what we call ordered atoms. So what that means is that if you took it under a microscope and looked at that mineral on an atomic scale, and you looked at the individual atoms, which are represented by our orange circles here, or spheres, they have to line up either in like a nice neat row or a very clear pattern that has symmetry to it. If it does not have any symmetry to it and it's more random in terms of its arrangement of atoms, like the one here on the right, it's not a mineral. Lastly, it has to be what we call inorganic. Just to give you a definition of inorganic, we can just say that it's not alive. So you can have organic carbon, you can have inorganic carbon. And the more technical definition of inorganic here means that it has to have inorganic carbon. But the way that you can think about it is that if it's alive, it's not a mineral. If it's non-living, it has a chance it could be a mineral as long as it satisfies the other criteria in this definition. So based on that, here is your next quiz question. So you have 4 substances up here. You have wood, you have ice, you have salt, and you have glass. And your job is to use those 5 criteria from the last slide and then decide if each of these substances is a mineral, yes or no. If you say yes, you have to tell me why it's a mineral. And if you say no, you have to tell me why it's not a mineral. Lastly, to finish up here, if you were physically in class, you'd get a bag of minerals, and then you would have to identify them and look at kind of their characteristics. But since we can't do that, I'm just going to verbally describe some of the ways that we can look at minerals and kind of identify what they are. So if we wanted to know if something is quartz versus halite, which is table salt, versus muscovite, which is a type of mica, versus biotite, which is a type of mica, olivine, talc, fluorite, calcite, all of these minerals, we have ways of doing that with using the characteristics of a mineral. So one thing that a geologist would do is that if they find a rock and it has minerals in it, they're going to look at what's called the habit. The habit is just the shape of the mineral. So is it shaped like a cube, which table salt tends to form that way, or pyrite, fool's gold, if you've heard of that, it will form that way. It could be a dipyramid. This is fluorite. So this is basically what you brush your teeth with. If you have toothpaste, you take this green mineral, grind it up. That's basically what toothpaste is. Maybe it's a prism, a sideways rectangle, so a rhombohedron, or it could be what we call tabular, which is just like sheets of paper. So when we're looking at minerals and trying to describe them, we describe them by their shape, and these are some examples of the shapes that can be used to describe minerals. Another way that we can describe minerals is hardness. So hardness of a mineral is measured on a scale. It's called the Mohs scale, so that's written right here, MOHS, so the Mohs hardness scale. Goes from 1 to 10, and it's a relative ranking. So 1 is the softest mineral that we have on Earth. That is talc, which is what talcum powder comes from, and a lot of baby powder and things like that. Makeup, plastics are all made with talc. And then as you go up the scale, the mineral will get harder and harder. And then 10 is given the hardest mineral rank. That would be a diamond. It's very hard to cut a diamond because it's such a strong structure to it. We have different ways of measuring the hardness. So we can use pennies. A penny, if you can scratch a penny with a mineral, it will have a hardness of 3 or greater. You can use your fingernail. So if you can scratch a mineral and leave a scratch on it with your fingernail, it has a hardness of 2 or 1. Then we also use glass plates. So you can have just like a little piece of glass, and you can take a mineral and scratch it against that glass plate. And if it scratches it, then you know it has a hardness of 5 or greater. Anyway, so at this point, you have another quiz question that you should be able to answer based on this slide here. Just a couple more properties and characteristics of minerals. So color is a pretty diagnostic thing for minerals. So there are certain minerals that are always going to be a certain color, but there are examples of minerals that can have many different colors. So quartz, for example, you can have orange quartz, you can have rose quartz, which is pink. You can have clear quartz, you can have milky quartz, you can have gray quartz, you can have amethyst, which is purple, citrine, which is orange, but I think I already said that one. You can have a form of quartz called tiger's eye. So color alone isn't necessarily the best way of identifying quartz, but for other minerals, color can be kind of diagnostic. Luster is a way that a mineral reflects light. So if you ever pick up a mineral, you can describe its luster by just kind of saying, like, is it shiny? Is it waxy, pearly, dull, earthy? All of these terms that we have here would be a way of describing how it reflects light. And that is what we call luster. Lastly, you can test a mineral and try to identify it by what's called a streak. To do a streak test, you can just take a mineral against a ceramic tile. So this is usually like a 1 by 1 inch piece of porcelain or ceramic tile, and then you just take a mineral, you scratch it against that tile, and you see what color it leaves behind. Just because a color of a mineral is gold in this example here, it could leave a streak that's green, or it could leave a streak that's red or black. So the streak test is kind of diagnostic for certain minerals, because just because it has a certain color appearance to your eye, it might actually leave a different color streak on a tile. Anyway, so that's why we do something called a streak test to identify a mineral. So just to finish up here, let's talk about why minerals are important. I asked you this question at the beginning. Different minerals are used for literally everything on Earth that you interact with on a daily basis. Your cell phone has a bunch of minerals in it. The laptop or computer that you're probably using to watch this lecture have minerals in it. Your goods that you consume on a day-to-day basis have minerals in it. So talc is the softest mineral on Earth. This is to show you that talc is used in plastics, ceramics, paint, paper, cosmetics, roofing, rubber, and a bunch of other products. So you interact with talc on a day-to-day basis. If you are sitting in a home and that home has walls, then you are interacting with a mineral called gypsum. Gypsum is what drywall or wallboard is made from. Salt, depending on your diet, you consume salt or halite. I already mentioned this one. This is fluorite. So if you take fluorite, you grind it into a powder. That's where toothpaste comes from. And then this image here is graphite. So graphite is pencil lead. Okay, so here's a good summary slide if you kind of want to read through the definition of a rock, and then what a mineral is, what an element is, and then look at it from the largest scale down to the atomic scale. This summary would help you do that. So at this point, you should be good to go in terms of finishing up the quiz, and then you have a minerals lab that you'll complete that has to do with kind of the everyday uses of minerals and some of the more common minerals that we see on Earth's surface and interact with.